In this section, we are going to be talking about function notation, dissecting what this complicated-looking notation really is saying in English, how we pronounce it, but also what it means mathematically or what it's asking us to do. We're going to look at function notation given an actual function. We're going to look at function notation given a table with some specific values. We're going to look at function notation and identifying parts of a graph using what the function notation is indicating for us to use. And we're going to wrap up just briefly by talking about piecewise functions a little bit. So let's go ahead and jump in here. So what we see in this first line in this table is f parentheses x. And the way that that's read is f of x. F of x. That's what you would say out loud if you were reading that. And what it means mathematically is a function in terms of x, or a function evaluated at x. So f parentheses 2, how we would read that out loud is f of 2, which would mean a function evaluated when x equals 2. Now the next one, the third one, looks similar to the second one. It says f of x equals 2. F of x is equal to 2. And what does that mean is it means set the function equal to 2, or what values of x make the function 2. The next one, f of 2x minus 5. What does that mean? It means take the function f and substitute in 2x minus 5 everywhere that you see a variable, or the function evaluated when you let x, or whatever the variable is, equal 2x minus 5. Now, something to note about this one here in red is that we would still have a function in terms of a variable after we substitute this 2x minus 5 in. The next one, g of f of x. This is a composition of functions. Composition of functions here. And what that means is that you're going to evaluate the outside function at the inside function. So you're going to take g and you're going to plug whatever f of x is into g. Similarly, the next one, g of f of 2, you're going to find f of 2, meaning plug x equals 2 into f, simplify that down to be something, then plug that into g. So when you're talking about these composition of functions, you're talking about working inside out. Inside out. The next one, f plus g of x, which simply means that we're adding together f of x and g of x. Similarly with subtraction, f minus g of x is subtracting g of x from f of x, or f of x minus g of x. F times g of x means that you're going to multiply the functions. F of x times g of x. And lastly, f divided by g of x means that you are going to take the function f and divide it by g. So hopefully we're getting this vocabulary down, and just to make sure that we really are understanding this vocabulary, we're going to work through some examples. But remember, on any of these where you see of x, that of x could easily be substituted in with a number. So you could see a number in its place. So let's make some room here so we can work through these 6 examples. Okay, so we are given f of x here. We are given a specific table of values for g of x. And then on one particular problem, we're given a new function, h of x. So we just need to make sure we're paying attention, we're using the right functions where we're asked to use functions. So number 1 is asking us to find f of 3. What does that mean? That means plug 3 into the function f. Well, f is 3x minus 1, so we're plugging 3 in for x. 9 minus 1 is going to give us 8. F of x plus 1 means that we would plug x plus 1 in. I'm actually going to do this in a different color, x plus 1, in everywhere that there was originally an x. So we're going to distribute here, 3x plus 3 minus 1, 3x plus 2 would be f of x plus 1. And lastly, f of x squared would mean that we're substituting in x squared where there was an x. Nothing can be simplified here, so we can leave it just like that. For number 2, we're being asked to use the function g and f, actually. So g, this is saying f of g of 0. Let's figure out what g of 0 is. G of 0 we're going to find using the table. So here's g of x. We want to know what that is when x is equal to 0. So that's going to come into play right here. G of 0 is 5. And you could think about this. I could rewrite every value in this table as an ordered pair if that helps you see it that way. So what we're going to do now that we figured out that g of 0 is 5, we're going to put a 5 here. So now we need to know what f of 5 is. Well, that would be the green function, 3 times the number we just found minus 1. So 3 times 5 minus 1, which is going to be 15 minus 1, which is going to be 14. Now we're going to do the exact opposite of that. We're going to find g of f of 0. So the first thing that we need to figure out is what f of 0 is. So f of 0, if we plug 0 in, 3 times 0 minus 1 is going to be negative 1. So we are now looking for g of the value we just found, negative 1. G of negative 1, again, we're going to get from our table, when x is negative 1, g is 2, so g of negative 1 is 2. So this is g of f of 0. Number 3 says determine f of x, determine when f of x equals h of x. So I'm going to take f of x, 3x minus 1. I'm going to set it equal to this new function, x squared minus 1. And now I'm going to move everything to the same side. So 0 equals x squared minus 3x. This I can solve by factoring out the greatest common factor. So this is going to be true when x is equal to 0. Or when x is equal to 3. And I'm just using set notation. And we're just going to be finding just x here. If we were asked to find ordered pairs, we could just plug those x values back in to find the y value and write the answer as an ordered pair. But to save us time, let's just find the x's. All right, I encourage you to pause the video and see if you can work through any of 4 through 6 on your own, and then unpause the video and see how you did. Okay, hopefully you have had some time to do this. This says, number 4, f times h of x. So this is really just saying we're going to take f of x and we're going to take h of x and we're going to multiply them. So 3x minus 1, and we're going to multiply that by x squared minus 1. This is just using the distributive property twice, or using the box method, the area model, to multiply. So that's going to give us 3x to the third minus 3x minus x squared plus 1, and I would rather that be in standard form. So I'm going to rewrite this so that my exponents go from largest to smallest. But this is f times h of x, a new function. F minus h, so we're going to take the same f of x that we just looked at, and we're going to subtract the h of x we were just looking at. So 3x minus 1 minus x squared minus 1. So now I'm going to distribute that negative minus x squared plus 1, and then I'm going to combine like terms, which there aren't any, so I'm going to rewrite it in standard form. F minus h of x is negative x squared plus 3x. Well, they work at like terms. Positive and negative 1. There we go. Now, for number 6, we're being asked to evaluate this at a particular value. So what does this mean? This means f of 2 divided by g, not h, which we've been using a bunch, not by g of 2. So what does this give us? F of 2 is going to be 3 times 2 minus 1, or 5, over g of 2, which we can get from the table. G of 2 is 9. From the table. So hopefully you're getting comfortable working with functions, understanding what function notation is. The math is pretty straightforward. The difficult part is dissecting and understanding what the notation is asking you to find. So if you need more help, go ahead and write those questions down, and I would love to help you out there. All right, let's move now to function notation and tie that idea to looking at the graph of a function. Here we are. So reading these things is the same as what we just talked about earlier in this video. Now, instead of looking at a table or looking at an equation in and of itself. We're going to be looking at the graph to find our answers. So we are given that this graph is the graph of the function f. We are being asked to find f of 0. So what does this mean? Where is the function when x is equal to 0? Well, when x is equal to 0, we're right here, and that looks like 2. F of 0 is 2, because we have the ordered pair 0, 2 on our graph. B says if f of x is equal to 2, then x is equal to, so this is asking us what x makes the function equal to. So I'm looking at right here is 2 for y. What x value makes the function equal to? Well, that x value would be 0. There's also another value. I can't tell exactly what that is, so I'm also going to sort of note x could also be approximately 1.9. Something is making it cross 2 again over here, but I can't tell exactly what that value is. What is happening when x is equal to -1? So where is x equal to -1? At this dotted line here. What's happening there? Well, the function is getting closer and closer and closer to the line here and here, but it's never touching it. So x equals -1 is a vertical asymptote. And what's happening when y is equal to 0? So y equals 0 would be the x-axis, or this dotted line here. And if you look at the right side of the function, nothing really interesting is happening. It's crossing exactly once. But if you look at the left side of the function, since this is a piecewise function, it's broken into 2 pieces. The left-hand piece over here is approaching that value. So at y equals 0, there is a horizontal asymptote on the left side of the function. So it's important to note that. So some of you may be thinking, I thought the whole idea behind an asymptote was that the graph can never cross it. Well, with a horizontal asymptote, we're saying that a part of the function is approaching that horizontal line and never reaching it. It is possible for a function to cross through it, but we're saying somewhere within the function, it's approaching that value and not crossing it. Okay, let's talk about our last idea, and that is piecewise function. Let's give ourselves some more room here. So we talked briefly about piecewise functions in an earlier lesson when we talked about absolute value and how an absolute value function could be written as 2 separate lines. So let's actually think about that really quickly. Let's think back and sort of review that idea. Let's say I had the function y equals the absolute value of x plus 2. Now, I could rewrite this as a piecewise function, because what absolute value really is 2 different equations of the line. So we have an equation of the line here that stops here, or I could say the equation of this ray, and then we have the equation of this line segment, or this ray. And how do we find those? We figure out what this magic number is that makes the inside equal to 0. In this case, that magic number would be -2 would make the inside equal to 0. So that's where we're going to have 2 different pieces. We're going to be talking about the red piece if x is less than or equal to -2. And we're going to be talking about the purple piece if x is greater than -2. There should be a negative here. There we go. So what's happening in the red piece? The red piece, the inside would actually be a negative number, but what absolute value does is it makes it positive. So what we would see if I was writing the equation of this line is that the slope of this line would actually be negative. So we would actually be looking at the opposite of what the function says, which would be -x minus 2, which should make sense. If we kept going, this would cross the x-axis at -2. So this is -x minus 2. The positive version is just exactly what we see in the function. This would cross at +2. The slope is up 1 over 1. So what we're saying is that absolute value is really 2 separate lines. The left hand of the absolute value graph is the negative version of what's inside, and the right hand portion of the absolute value is the positive version of what's inside. So this has been split into a piecewise function. So what is a piecewise function? It's just one function that's built with pieces of other functions. Don't be scared by the notation. It's really not as complicated as it seems. So let's look at this piecewise function here and just make sure we understand how to read it, and then we're actually going to move on and talk about how to graph it. So there are three pieces here. There is a piece where x is less than 0. There is a second piece where x is equal to 0. And there's a third piece where x is greater than 0. So depending on the x value that we're using, we're going to use a different equation to find that value. So for all of the values, so we're being asked to find f of 0, f of -2, and f of 1. So f of 0 would fall into this middle. I'm going to label these 1, 2, and 3. The second part of this piecewise function, the second piece, because it says if x is equal to 0, use the middle piece, and the middle piece just says the answer is always 2. F of -2 would be an x value that is less than 0. -2 is less than 0. So f of -2 would mean that we're using the x plus 1 piece, -2 plus 1, which would be -1. And f of +1 would mean that we're using the equation where x is greater than 0. So f of +1 would be -1 squared plus 4, which would be 3. So when you're looking at a piecewise function, what I really want you to focus on is understanding what each individual piece is telling you, when to use it, what values get plugged into each piece. So what we're going to do lastly, and this is not something I want you to stress out about too much, but it is something I want you to consider, is we're going to actually sketch a graph of this piecewise function. So let's start with piece 1. Piece 1, x plus 1, if x is less than 0. So if x is less than 0, we're looking at a line. We're looking at a line that has a slope of 1, and it has a y-intercept of 1. But we don't actually get to that y-intercept. So what that means is the y-intercept is actually going to have an open circle since x is not allowed to be 0. Since x is not allowed to be 0 in this part of the function, the green part, it's going to be an open circle at 0, 1. So normally we would go up 1 and right 1, up 1 and right 1. However, this function, the line part doesn't exist. The line part doesn't exist on the right of the function. It only exists on the left. So we're going to go actually down and left 1, down and left 1, until we run out of space, and we're going to connect and have an arrow going to the left. Because all the way down to -infinity, this x plus 1 is the part of the graph that we're using. Now we have an open circle when x equals 0, but we know what's happening in the actual entire piecewise function. When x equals 0, the function is 2. So 0, 2 would be right here. Now, at that part of the function, x is equal to 2, that's a constant. It's not a line, and this only exists at that exact value. So if x is 0.1, it's no longer 2. We're using a different piece of the function. So that little ordered pair, that plotted point, is the only thing that we need to graph when x equals 0. And then the last piece of our function, -x squared plus 4, if x is greater than 0, well, if x was equal to 0, then we would be at +4. That's going to be an open circle, again, because it's not allowed to be 0, but we need to know exactly what's happening right up to 0, meaning we need to be able to look at this function and use it to get an idea of what's going on at point 1 or point 2. Now, this is a parabola that's opening downward, has that vertex at 0, 4, so we would have a point here using our properties of graphing. We'd have another point down here, and then we can connect to make this an upside down parabola. And that's sketching the graph. So again, you could be asked function notation questions like approximate f of 2, or tell me what f of -3 is, and you could use the graph to identify those values. So let's recap what we learned in this section. The goal in this section was that we could read and understand function notations, that we know how to actually say it out loud, and we know what it means mathematically we need to do. We talked about looking at tables and functions and finding values and different functions, f of 3, f of x plus 1. How do you do that with an equation? How do you do that with a table? We talked about the different operations like multiplying two functions, subtracting, dividing. And then we moved on to analyzing a graph and identifying key parts of a graph. And then lastly, we wrapped up by talking about what piecewise functions are, how we can use them, and we tied that back to absolute value, which we talked about earlier on. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.